The topic which we will be discussing today is about the safety with industrial robotics. So I have planned this session in such a way that the initial part, for about some 10-15 minutes, we will be discussing about the fundamentals of safety or the need and importance of safety engineering in an engineering activity. That is what the first 10-15 minutes we will be discussing. Then after that, I will be discussing a few statistics related to the growth of robotics and how human workforce is interacting with the robotics. And the later part, on the third part of the session, I'll be focusing on the safety aspects of the industrial robots. So this is how I have planned the session for today. So with that, we will start the discussion for today. So first of all, before going to this overall dimension about the industrial safety, first of all, I would like to introduce about the industrial safety, the need of industrial safety, why industrial safety is required. We can say that there are three prime reasons for us to focus on industrial safety. And one is the humanitarianism, because we as a human being should have the humanity and empathy towards the other living beings, not only the human beings and the other living beings. So that is one very fundamental aspect of the industrial safety, or the moral, it forms the moral basis for the field of safety and health. And the second thing is the law. So basically the law which is given by the different government agencies or the enforcing agencies, they actually give the society's moral code. So we live in a society and we should have a moral code so that our life is not disturbing other people and also the freedom of the other fellow citizens. And that is the second reason why we need to have the safety, because in the law enforcement agencies, the legislations all have a specific requirement that whatever the process you are carrying out, the process should be less hazardous. It should be less hazardous to the environment, and also the loss of life to people or to any living being has to be totally avoided. So that is the law. That is the point that each and every law with respect to industrial safety is deliberating all the times. And the third major reason is, of course, the economic part of it, the economic part of any operation. So the third reason is the cost. Some government and businesses, basically, they have this also as their final. This forms the final basis for any business. Ultimately there should be some profit out of it, and the system, when you have a safety system, obviously the people are going to work in a better environment, which will definitely increase the productivity of any organization, not only the manufacturing organizations, also the service organization, or whatever the sector may be. If you give a proper, good working environment to the people, you will be having a good returns for that. So that is the other reason why industrial safety is very, very important. And the damage to the environment also causes irreparable losses to our Mother Earth, because we should also take care of our environment, and only then our future generations will be having a good life on this earth. So these are the three. So that's why we say that these are the three primary reasons why we should follow or why we should practice industrial safety measures or occupational health and safety practices. So one is humanitarianism, the other one is the law, the third one is the cost. And with that, that's a small introduction. I'd like to present some statistics given by ILO So ILO is nothing but your International Labour Organization, which is headquartered at Geneva, Switzerland. And basically, they have some statistics. They are the organization which are responsible for developing the labor codes and developing the work duration. For example, 8 hours work duration was basically derived, or they have given us the recommendation. Also, not only the recommendation with respect to the work duration, with respect to the work quality, with respect to how to carry out the work. So all these guidelines or the references are made by this ILO, this International Labour Organization. And this ILO, the data says that every 15 seconds the worker dies from a work-related accident or disease. So an accident, you can say that it is caused at that particular instant, or a disease might be a chronic development over a period of time. Over a period of time, a person working in an unsafe environment, say for example, in a polluted environment, he may develop some lung disease, and this may lead to fatality of the particular worker. So every 15 seconds, there is a worker dies from a work-related accident, and every 15 seconds, 160 workers have a work-related accident. So an accident, 160 accidents, or 160 workers are affected by some accident, work-related accidents, every 15 seconds. Every day, there are about 6,300 people die because of occupational accidents or work-related disease. So disease, in the sense, I would say that it's a chronic in nature. It's not something happened on the previous day and the person is dying on the next day. It is something chronic, might be some 3 years or 4 years or even more than that period. The worker is affected by some adverse environments at the workplace, and that has taken his life. So in that way, you can say 6,300 people die because of occupational accidents and work-related diseases. The other three statistics, and also you can see that every year around 317 million accidents occur on the job. That is normal work, and out of the 317 million, about 2.3 million persons of deaths occur every year. And when you take the loss accounted because of this accidents or because of this unsafe work environment, the loss that is accounted is somewhere around approximately 4% of the global gross domestic product. So that is the GDP. So if you can improve on this, if you can reduce the number of accidents, obviously it is going to improve the economy of the country also, and subsequently the economy of the world. Okay. You can see that a small safety pyramid it is given. So basically it shows, it actually gives you the insight about the number of accidents, number of incidents occurring, or number of unsafe conditions or acts that are occurring, and finally to the fatality. It means, so generally people think about the fatal accidents. They remember only about the fatal accidents. Fatal accidents are nothing but when an accident where there is a loss of life. So loss of life thing is called as fatal. So even before fatal accidents, people may be affected because of injury, and there may be some lost time because of the accidents. And even if you don't have an injury, sometimes there may be some near miss incidents. Near miss incidents are, there is a failure, but no one is affected out of that. No damage is affected, no damage is inflicted on the property, or no damage or no injury is inflicted on the workforce or the human beings. But still, the incident has taken place. So that is the near miss incident. So when you see the statistics, you can say that around some 3 lakh unsafe acts and conditions, they will lead to an incident around 30,000 incidents. The 30,000 incidents will lead to some accidents where the time is lost because the person has injured or the property has been damaged, the machinery has damaged or the workplace has been damaged. So for replacing that, you require some time, and that is around 300 in numbers. And this 300, then when you come further down, you can say that around 30 numbers or 30 persons or 30 serious injuries are there. So injury, what I mean here is a permanent injury, a permanent disablement. So a person losing a hand or losing a leg, or he has lost some ability in his day-to-day life. So that is termed as permanent disablement. And finally, you come to that one fatal accident where there is a loss of life. So when you put together all these things, we just remember that one accident alone. But when you go deeper, you can see that there is a permanent disablement, there is a last time accident, and there are near misses which are also equivalent to an accident. So that the incident has occurred. Only the difference is there is no loss to the life or property. So you see the importance of the industrial safety, because we should focus on all these aspects. We should improve all these unsafe acts, unsafe conditions, so that the near misses can be reduced. And once we reduce the near miss accidents and minor incidents, we can reduce the last time accidents, and finally we can reduce the fatal count to almost zero. Now, not only the fatal count, also we should be able to reduce the permanent disablement also to zero. So that is one of the main objective of industrial safety, and we should know that these many accidents occurs or incidents occurs day by day. Next slide. So, few important terms before going to this industrial, before going to the actual discussion. So, safety. The definition for safety is the state of being relatively free from harm, danger, injury, or damage to the environment. So safety is a state of being relatively free. So we are supposed to be in an atmosphere where we don't have any harm or any danger, or we are not having any injury or damage that is occurring around us. And safety engineering is the application of engineering principles and practices to the recognition, evaluation, and control of hazards that can lead to the accidents and incidents. Sorry, that can prevent the accidents or incidents. So safety engineering is the application of engineering principles. So we don't see safety as a out of engineering. We should follow certain engineering principles to recognize, to evaluate, and control the hazards, so that the accidents or incidents can be prevented. Hazard is a very important term, because we use that particular term often in industrial safety. Hazard is a potential or inherent characteristics or property of an activity, or it can be of a material, it can be of a condition or a circumstance which is harmful, or which can produce adverse effects, or it can create some adverse events to the human life or the environment. So that is the hazard. So hazard is a potential risk, potential danger. You can simply put it in a simple word. It is a potential danger. Whereas risk is nothing but the chance or likelihood of an adverse event and the potential severity that may result. So it is nothing but there is a hazard, but how likelihood is that hazard is going to affect you. That gives you the probability of risk. So risk is nothing but the probability of the hazard to affect you or to cause the damage to the life or environment. So that is nothing but the risk. So in brief, these are the four basic fundamental terms which I would like to introduce all of you. And you can see the commonly used approach for safety, for hazard control and safety improvement. So initially, you have a continuous improvement system for this. So first, you have to identify the hazard, then you do the risk assessment. Risk assessment is nothing but there is some risk. So how severe it is going to be, or how repetitive it is going to be. So these two are the risk assessment parameters. So how severe it is going to be, how repetitive. So if there is a highly severe risk and it is going to occur frequently, then you have to focus on that particular risk initially. If there is a risk that is very creating a very less severity and it is not occurring frequently, then that particular risk can be dealt much later in the order. So first you have to identify the hazard, then you do the risk assessment, then we have to control the risk. So risk control is basically done by eliminating the hazard. So we have, so you have these 5 controls. So that is known as the hierarchy of controls in safety engineering. The first and foremost control is the eliminating the hazard. So it will be best solution for any hazard removal is to eliminate the hazard. There should not be any hazard. Second best thing is to substitute the hazard with less hazardous material. Say for example, there is a chemical. There is a hazardous chemical. If you can substitute with the water, it is almost a nil hazardous material, then I can go for that substitution. Similarly, eliminating the hazard, say for example, you are having a chemical you are using in your particular product. This chemical need not be used, or when you, after some analysis or some experiments, you find out that there is no point in using this chemical, then obviously you can eliminate the hazard. You can, if elimination is not possible, you go for the substitution. Then the other two controls, the one is the engineering control, the other one is the administrative control. So this again we will around 6th or 7th slide we will be seeing it more detail. So these are the few important terms which are very important in industrial safety engineering. These are one of the very fundamental terms. So at least without which we cannot have a proper understanding of this particular session. So that's why I'm insisting on this particular terms, especially the hazard and risk. The hazard is a potential danger. Few more terms about accident. So accident by definition, by Indian standard, you can see the Indian standard is given. So IS 3786, the Indian standard. As per the Indian standard, accident is defined as an unintended occurrence. So it is not an intended occurrence. It happens in an unintentional way, arising out of or in the course of an employment of a person resulting in injury. So only the definition talks about the employment of a person, whereas even modern industrial safety practices, environment is also given an equal weightage, equal representation with respect to the human life. So human life, not only human life, living beings and the environment are very, very important in terms of industrial safety. And the other thing which we generally say is accidents always happen. So that is the wrong thing. We should always remember that accidents do not happen. They are always caused. They are always caused by some unsafe act or some unsafe procedure or some unsafe conditions. So an accident is always caused. It is caused by some mistake. The mistake may not be known right away after the accident, but if you analyze, you investigate the accident properly, you can always say that there is some cause for that accident, and you can always put down that cause. You can categorize under these three factors. So one is the unsafe act. So unsafe act is nothing but I'm an operator of a machine. I purposefully don't follow the safety standard operating procedure. So before starting the machine, say for example, I have a lathe or I have a milling machine, which is supposed to be checked for all proper electrical connections. Say for example, I just go there is a standard operating procedure that I should check for the electrical connection, but I don't do that. I straight away start the machine. There is some earthing problem or there is some leakage of electricity which can result in some electrical injuries or even some electrical shock, which sometimes can also be fatal. So unsafe act contributes to around 88% of the accidents. So the reason for 88% of the accidents are unsafe acts because this 88%, 10%, and 2% are derived from some broader. Some accidents have been analyzed, and with that, the statistics have been obtained. And unsafe condition, it is contributing to some 10% of the accidents. So unsafe condition, you can simply put it in a way that there is a slippery road. There is a slippery road, and this slippery road can skid your vehicle, or after rain, there is a wet condition in your the building premises, so which also can lead to some electrical shock or something like that. So this 10% of the accidents are due to unsafe conditions. Then the other 2%, remaining 2% is purely because of the factors which we don't have any control, which are the natural factors and some other factors, some disasters you can say, or like we have with this coronavirus pandemic, so something like that. We don't have control over that. We don't know what was the real reason for that, but still it has happened. Sorry, it has caused, it has occurred, and the other 2% of the accidents are due to this natural and other factors. So this is how the accidents can be classified. Always we should remember that we are the reason, or somewhere some unsafe conditions are the reason for the accidents to occur, and they do not happen just like that. There will be some real reason behind the accident. Apart from accident, we also have the another definition for incident. So incident is nothing but the near miss event. So this is very much depicted in this figure. You can see unsafe accident, unsafe condition. It is given in the first image. So there is some damage to this wire sling. So this wire sling is by which this load is suspended. It is lifted by the crane, and there is some damage to this wire sling. And this wire sling, the damage to the wire sling is an unsafe condition because you do not know when it is going to fail. So this is an example for unsafe condition. Then unsafe act is nothing but a person who is standing beneath the suspended load. So if there is a suspended load and the person is standing beneath that, or the other way, the operator suspends the load over a person who is standing. So this is called as an unsafe act. This can be either by the person who is standing or the operator of the crane. But this is done purposefully, or it is an unsafe act by a human being. So this also can lead to an accident. And near the event, that's what I told you. The suspended load falls down. It falls down on the floor without any damage to the human life or environment. So in that case, you can say it is a near-miss event. Whereas the accident, when it falls over a person or it damages some machine or some property, then it becomes an accident. But in any case, we cannot just like that ignore all the near-miss events or the incidents. So we are supposed to analyze all the near miss events. We are supposed to analyze all the incidents. Only then we can overcome, or we can analyze and we can find the real cause of the accidents. So when you see this, the previous statistics, so this also holds good here. So even though there is some incidents or some lost time injuries, the fatality is going to be very, very minimum. But we just think about that fatality. The general perception is to think only about the fatality, not to consider all the near miss incidents or the injuries, permanent injuries caused by the accidents. So this is another set of definition about the accidents, and for making you to understand about the unsafe condition, unsafe act, near miss incident, and accident. And moving towards safety, generally you have this, the traditional approach towards safety is having the 3 E's, the engineering control. You have having the engineering control, then you educate your workforce, and also not only the workforce, whoever comes into your premises, you have to educate them to have a proper safe conduct during their visit to your premises. And if you are giving some engineering controls, you're educating you're giving training to your operators, still there is no improvement, then obviously the other next thing is to enforce them, is to have strict orders, develop strict standard operating procedures. If there are some deviations, you give some penalty, you give some appropriate treatment for not following the safety procedures. So that is how the traditional approach for industrial safety has been done for so long. And can also the second image again shows the same thing. If there is an accident, you need to know what is the unsafe act, or whether it is the unsafe condition have led to the accident. Then you educate, you have some engineering controls, and both cases you try to enforce them. So this is how a traditional approach for safety has been done for a long period of time. Hierarchy of controls, which I told you earlier. So the hierarchy of controls is with respect to the hazards, and this was developed by NIOSH. NIOSH is nothing but the abbreviation for NIOSH is National Institute of Occupational Safety and Health. And the hierarchy of controls, first you have to eliminate the hazard. That is the best solution you can give for providing a safe environment. The second one is the substitution. You replace the less hazardous condition. You replace the more hazardous conditions with a less hazardous condition, or less hazardous material, or less hazardous process. Engineering controls, you try to reduce the exposure, try to reduce the hazard by giving some engineering controls. Say, for example, in the case of a noise pollution, you give them the muffler. If there is some, that comes under PPE. If there is a noise control, you just try to reduce the noise by giving there is an excessive noise from a machine. You try to cover the machine with some enclosure so that the noise is not coming out of the machine. And also, if there is some welding is taking place, you are doing some welding operation, the welding fumes are generated, and you can have some fume extractors. So it is an engineering way of extracting the fume. You try to extract, it is very similar to the exhaust fan which you are using. So the fume extractor extracts the hazardous fumes that are coming out of the welding operation. Then administrative control, you give standard operating procedures, you give some written documents. Also, you train your employees so that they follow the proper standard operating procedures and safe practices. Then finally, you come to the personal protective equipment. that is as the uh, least effective method, but still that is a very good effective method. You give them proper personal protective equipment, like you give them the helmet, you give them the goggles to protect the eyes, you give them the mufflers to protect the ears from noise pollution, you give the mask, you give the respirators, also a thermal suit. If the persons are working in a high temperature environment, you give them the thermal suit, you give them the safety shoes so that any fall of objects can be not damage or cause the injury to the food. So these are some of the examples of personal protective equipment. So a small example of how this hierarchy of controls is associated with the present COVID-19 pandemic. You can see the hierarchy of controls for COVID-19 spread control. So the best thing for this COVID-19 spread control will be isolate yourself from the world, or you try to eliminate the coronavirus, or you try to destroy it. So that is the ultimate way to be free from the COVID-19 virus. But that is not possible. So far, the virus is not eliminated. Also, you cannot isolate yourself completely the world. So, then you go for the next step or the next control. You try to substitute. So you try to go for work from home practices. You have started work from home practices. You work in remote. Schools, colleges are being in online modes. So this is another way to prevent yourself from this pandemic. So you cannot eliminate, then you immediately go for the substitution. And engineering control is how you, with some gadgets, like you measure your temperature, you measure your oxygen saturation level, and you try to use sanitizers, you try to use you have some practices like washing your hands. These are some of the ways, some of the engineering ways by which you can have a check on the coronavirus. And administrative control is just like standard operating procedures by the government have been issuing a lot of standard operating procedures for the past 1.5 years. So which means that you have to follow those practices, like maintaining social distancing, keep a distance of 1 to 2 meters while talking to people, or 6 feet of social distancing is what the government prescribes. So that is an administrative control. And wearing PPE, so you wear your mask when you are going outside. So that is equivalent to the PPE. That is the PPE you are using, personal protective equipment. So this is how this hierarchy of control can be equated or it can be related to the present COVID-19 situation. So this is how, in general, the hierarchy of controls is applied to all the industrial safety practices, or it is general in the safety engineering field. Moving on to the next, so I think I have given some brief introduction about the industrial safety engineering or industrial safety practices. Then moving on to the next part, where some statistics about the robotics, the growth of robotics, because finally you will see this just to give an idea about the growth in the robotics field. So this is a statistics given by the International Federation of Robotics that is located in Germany, which is one of the two apex bodies which controls or which monitors the growth of robotics worldwide. So the other one is located in US, that is the Robotic Institute of America, and the other one is the IFR, the International Federation of Robotics. So they have given some data. This is just a preliminary data for the past year. You can see this data is accounted only up to July 2021. The final data is expected to be released by the month of October 2021. So if you see, for the past 10 years or the last decade, the annual installation of industrial robots in the world, they have given this, the units are in 1,000 numbers. So it is 1,21,000 robots or installation robots have been in the industrial robots. And again, I'm saying that we are more concentrating or we are just focusing on industrial robots. So about industrial robots, around 1,21,000 industrial robots have been installed in 2010. Then you can see the growth, and also in 2019 there was a small dip, and 2020 also the data is not complete so far, but this can be related to some pandemic, to this COVID-19 pandemic. So the growth of robotics or installation of robots have been consistently increasing throughout the world. So this is clear from this particular statistics. And again, you go the much deeper sense, the operational stock of industrial robots. So that is, so how many robots are, so the previous data, how many robots were installed, but whereas some older robots before 2010 or 2009 are also functioning. So how many operational robots, industrial robots are present? Again, it is still on the increase. You can see till 2000, from 2021, 10,21,000 in 2009, it has reached about 27 lakh odd industrial robots in the year 2019, and the data is of 2020 is expected in October. So it is the operational robots are also on the increase. And in which sector these robots are used? You can see the automotive sector. Again, in 2019, the automotive sector has seen the largest number of operational robots across the world. 9,23,000 robots across the world, automotive sector. Then you come to the electrical and electronic sector, the electrical packaging, electronics packaging. In those sectors, you have around, again, you can see the improvement or increased use of robot. Then metal and machinery, another important sector where mostly welding robots are used. Robots are used for painting purpose, especially in the automotive industry. Plastic and chemical product manufacturing, because chemical products sometimes they are really hazardous. So you want to have a safe solution. So you have to have lesser interaction of the human with the chemicals. So you go for a robot. And food industry and other industries, you can also see the improvement or increase in the usage of the robots. And the operational stock of robots, industrial robots by application, you can see the material handling is where you are using the robots at the maximum level. So it is a pick and place robot. You are picking a product. The robot is taking some distance and it is placing in the required destination. So the material handling robot used in many warehouses, like best example is the Amazon and this online e-commerce warehouses. So all the warehouses are situated in centralized location. So many robots are used there for the material handling purpose. Similarly, welding robots, because welding is a very hazardous operation. It is involved with the generation of fumes. This fumes is very, very hazardous to the human health. You inhale, it is carcinogenic in nature. Carcinogenic in nature means the welding fumes can create or can lead to cancer. So this welding fumes, so in order to avoid the human interaction, more and more robots are being installed in the welding application. And also in the assembly application, where if you take this precise electronic products, like you have your mobile phones, have your processors, especially the microprocessor industry, it is a very tiny chip, and it is placed, the size is of somewhere around microns to micrometers to nanometers, and those precise or those tiny particles has to be handled precisely, and for that purpose we use the assembly robots. Then clean room robots for cleaning a hazardous workplace, dispensing robots just for delivering some products. So when you take the most of the robot application is taking place in handling, welding, and assembly. So again, in handling, we use pick and place robot. Welding, there is a specific welding robot. The interpreter is going to be a weld weld gun, and sometimes in assembling a miniature version of the pick and place robot. The end effector will be giving a precise movement for handling the electronic assembly. It gives a general idea about where these robots are used. And by country, there's another statistics. You can see China is using the largest installations of industrial robots, then followed by Japan, US, and India is somewhere we are utilizing around 4,300 units of robots in the year 2019. And again, by robot density, you can see by which country uses the largest number of robots. So the highest is Singapore and Republic of Korea. Then the world average is around some 113 number of robots installed per 10,000 employees. So this is the ratio between the number of robots installed and the number of employees in the organization. So if there are some 10,000 employees in the organization, Singapore is having around 918 robots. So which means that there is a human interaction between the robot and the employee. There is an interaction between the human and the robot. So which is very important for us, why we need to look into the industrial safety aspect, because it is not a machine, it is not a robot, it is which is working in a secluded environment. It is also working along with the human beings. Human beings are teaching the robots, because initially whatever the programming is you are doing, whatever the assembly of the robots you are doing, it is done by the humans, and the hazard is existing there itself. When before the programming itself, the humans are interacting with the robots. I mean, the humans are the people who are assembling the robot, who are programming the robots, are interacting with the robot before the usage. So that state is very critical, because the robot has not been programmed. So there can be any sort of motion from the robot. This motion can lead to some accident. So that's why you can see the number of people which the robot is interacting is also significantly higher. And that's why we need industrial robotics safety also to be associated with industrial robotics. So with that brief statistics, I will be just giving a small background about the industrial robotics, a few glimpses about industrial robotics. So the definition, I think by now you would have come across all these definitions, but still from standards point of view, I would like to give the definition from the two agencies. One is the Robotic Institute of America, which is one of the robotic associations. The other one is the IFR, International Federation for Robotics in Germany. So the two definitions are given here. It is a reprogrammable multifunctional manipulator. It is designed to move materials, parts, tools, or specialized devices through variable programmed motions, perform a variety of tasks which also acquire information from the environment. So it says that it is a programmable device and it is having a multifunctional manipulator. And these two places are where the hazard is existing in the industrial robot. So when you are programming, when you program the robot, it will say it will follow whatever the program you have feed into the robot. But before that, it is like an autonomous machine. It can have its own movements if you are not properly protecting yourself or if you are not properly monitoring. So there itself, the hazard is existing in the robot. And it is a multifunctional manipulator, so it can be used for multiple applications. Like when you change the end effector, like from a gripper to a welding gun to a painting spray gun, or to a small precise assembly manipulator. So based on the manipulators also, the level of hazard varies in a robot. And as per ISO 8373, there is a standard defining the robot. So it is again a similar definition is given: an automatically controlled, reprogrammable, and multi-purpose manipulator, which can move in 3 or more axes. So that the axis information is given in this particular definition. So it can move in 3 or more axes, which means that its movements are occurring in all 3 axes. So the operator or the programmer has to be much aware of these movements also. And the word robot has come from the word robota, so which means artificial human-like creatures, which was used first in some theater play and written by Karl Kappa in 1920. So the robota means work in Slavonic languages. Slavonic languages are something spoken in the areas in European countries and the Asian countries. So where this Europe and Asia is coming together. So there the Slavonic languages are being spoken, and in the robota means work. So that is from there we have got this particular word. And industrial robot and laws of robotics. And industrial robots are programmable, multifunctional mechanical devices, which is used to move. The same definition is repeated, and you can also say that the laws of robotics, which was proposed by the father of robotics, Isaac Asimov, in his book I, Robot. So he has written a book, I, Robot, in 1950, and there he has specified the 3 very important laws of robotics. And this laws of robotics, when you read the second and third one, even the first one, you can say that he has more emphasized on the safety of the robotics in the laws of the robotics itself. So the first law reads as: a robot may not injure a human being or through inaction allow a human being to come to harm, which means that a robot should never cause harm to a human being. So that is the simplest way the scientists have explained. The father of robotics has explained that a robotic should be a very safe device or safe equipment. And a robot must obey orders given by human beings. So you do some programming, the robot has to follow that. But there is a specific exclusion. It should not accept the orders where it will conflict the first law. So first law says that it should not injure the human beings. So the second law says that it should follow the human orders, but still it should hold the first law also. The first law should not be violated. The third law says that a robot must protect its own existence, and its existence, it should protect itself. It should not damage itself. A robot should not self-destruct itself. It should exist. And again, the existence also without conflicting the first and second laws. So the existence should be there for not causing any injury to the human beings, and also it should follow all the orders given by the human beings. So these are the 3 very basic laws, we call the laws of robotics, given by the father of robotics. So by virtue, you can sense that these 3 laws are almost forming the basis for the safety with industrial robotics. And classification based on design, I think by now you would have come across all these classifications. So just I wanted to know why I'm showing this is because we are more interested in the work envelope or the workspace. So the Cartesian coordinate robots, cylindrical coordinate robots, spherical or polar robots, SARA, the selective compliance assembly robot, the Delta robot, articulated joint robot. So all the robots, if you see, there is this particular work envelope or workspace defined for this robot. So it is very important for the programmer or the operator to not to go into that workspace by the robot without any proper safety measure. So that is very clear from this by defining this workplace. So when you know that this is the type of robot which you are working, so you should be well aware of the work envelope of that particular robot, because the work envelope is where the robot will have its motions, and if there is some contact you are making with the robot inside the work envelope, then that the robot motion may take place and that can lead to severe injury. So as a robotic engineer or a person who is working in robotics should be very well aware of the work envelope of that particular robot. So if you are working with a articulated or joint arm robots, which is having some 6 degrees of freedom, so you should always know that what is going to be the work envelope. Or a simple Cartesian type of robot, you should know what is the work envelope. So knowing the work envelope, if you know the work envelope of the robot properly, then you are following the safety norms for that particular robot. So that is clear with this classification itself. The classification based on control systems. So the two control systems that are given for the robot is the servo robots and non-servo robots. So servo robots uses sensors. The sensor will sense the robot's axis. The sensor will sense the position and velocity of each manipulator or end effector, and the sensor will give the feedback to the programming. So which means that the default programming or the reference programming you have, and the sensor always gives you the feedback about the robot's position or the manipulator's position. So which always the programs are compared, and any deviation which can be corrected then and there. So what I mean to say is a servo robot is less hazardous than the non-servo robots. So a non-servo robot is where you don't have this feedback capability. It is not having any sensors, and also it is only controlled by mechanical stops and limit switches. So there will be a limit switch, and the robot's arm or manipulator, if it is hitting the limit switch or it is coming into contact with the limit switch, then automatically the limit switch, the movement or the motion will be reversed. So there is no control, or there is no sensor which is monitoring the motion of the manipulators or the robot axis in a precise manner. So that is missing in non-servo robots. That is present in servo robots, which makes the servo robots a much better option than the non-servo robots. So servo robots are less hazardous and non-servo robots are more hazardous in nature. Similarly, the robot classification based on the path generation, if you see, there are 3 different paths are used. So one is the point-to-point path method. The second was the controlled path method. The third one is the continuous path method. So the first one, point-to-point path, the path of the robot is defined from one discrete point to another. It is like point A to point B, then from point B to point C, then from point C to D, again from D to C or D to B. So it moves from the programming is done, the path generation is done from one point to the other point. Whereas the second one is the controlled path. The controlled path is nothing but the robot will follow a predictable path. You have written some program. The robot will follow that particular program or the path defined in that particular program. The movements are achieved. Whereas continuous path generating robots it is more like a small distance is divided into many number of spatial points. So there are, say for example, there is 1 centimeter length and this 1 centimeter is even divided into 100 times or 1000 times, and those points are connected. So it is more similar to a finite element application, finite element analysis. You are defining the path, or you are dividing the path into many small successive spatial points. So these spatial points are taken into the memory of the robot, and this makes the continuous path generating robots as less hazardous, because the path is almost traced in a continuous manner. The spatial points are very close to one another, which means that any deviation from the planned path or programmed path is going to be very, very less or minimal. Whereas when you take the case of controlled path, it is slightly hazardous than the continuous path generating robot, but still it is better than the point-to-point path robots, because point-to-point, you just have to go from one point to another. It can choose any particular way. It can go clockwise or it can go anti-clockwise. But that makes the movement of the robot. You cannot judge the movement of the robot, so the robot can take any path. But when you take the continuous path generation, you will define the path appropriately. So the robot will move in that particular path. And again, it will come back to the original question by the defined path only. There won't be any changes in the paths of the robot, as in the case of point-to-point path robot. So what does it mean? The continuous path robots are very, very less hazardous. So the moment is there is no deviation. There is much less deviation in the case of the robot path or the manipulator path. So these are the three categories of robots. So one should be always an operator or the programmer who is working in the robot has to understand the work envelope. He should always be aware of the work envelope of the robot. Second one is the control system. A servo-controlled robot is much better than a non-servo robot, because the sensor gives the feedback and the robot will work based on the feedback, and this makes the robot as less hazardous one. The third one is the classification based on path generation. A path that is generated with a succession of spatial points, a large number of spatial points, will give you a good control over the movement of the robot, which again makes the robot as less hazardous one. So this is about how we can relate the hazardous nature of the robot and the types of the robot. Industrial robotic components. These are the four major industrial robotic components. So the first one is the robot's mechanical unit. The structural frame and the payload. So the payload is nothing but the amount of weight the robot is handling. What is the maximum amount that it can handle? So that is the payload. So the robot's mechanical unit is defined by structural frame and the capacity of weight that it can lift or it can operate. Then power source or supply. There are three different power sources. The one is the pneumatic power source, which uses less pressurized air. Hydraulic power source, which you use the industrial oil. So the pressure level of this pneumatic system is less than the hydraulic system. Hydraulic system, you are using industrial oil. So usually it is at high pressure and often used for medium to high force or weight application. So when you take the case of payload, so pneumatic powered robot, the payload will be less. Hydraulic powered robot, the payload will be more. Electrically powered robots are the robots which are more prevalent in the industry. It is operated either by the AC current or DC current. Electrical power is used to supply energy to the electromechanical actuating mechanisms. So electromechanical actuating mechanisms are nothing but your sensors and also your actuators are powered by the electrical current. So this again can still lift more or heavier payloads. motion control is much better in the electrical powered robots, because electrical powered robots, if you switch off the power, the robot's motion can be controlled easily. It will come to a stop immediately. If there is an accident, if there is some adverse thing is happening inside the robotic chamber or the robotic workplace, you can just put your emergency stop button. You just make the emergency stop. Immediately the robot will come to stop. Whereas that is not possible in the case of pneumatic powered or hydraulic power. So it is always better to go for electric powered robots. It is almost very safe to work with the electric powered robots, but still, on the other hand, you have some electrical hazards also in that, because electricity is itself a hazard. The hazards are nothing but you can obviously know that electrical shocks, high voltage electrical current are real hazards to human health. Robot controllers, you can see the sensors, microprocessors, and programming forms the robot controllers. Four major components of the industrial robot is the robot tooling or the end effector. So the end effector basically is depending on the application. So it can be a gripper where it is doing a pick and place operation. It can be a weld gun where welding is done, or spray paint gun. Hazardous spray painting is done for automobile industries. So, but whereas why I would like to emphasize here, what I would like to emphasize here is the electrical power robots are much better in control. You can control it in a much better way, but still you have to always look out for the electrical hazard, how to deal with the electrical hazard, how to deal safely with the electricity. That is also another important aspect you have to keep in mind. Robot accidents. So now I would like to introduce you to some of the robot accidents which have occurred previously. For certain reason, I'm not sharing any of the images of such accidents because because it may be sometimes disturbing to see some images of such accidents. So for that particular reason, I'm not showing any images, but I'll just give you a brief how what are the major causes or what are the different types of accidents that has occurred with respect to the industrial robots. So examples of robotic accidents, like I told you earlier, all accidents will occur in the robotic envelope or the envelope, operating envelope. So a robot's working envelope is a very hazardous place. So a person who is entering into the robotic working envelope should be very careful, and it is not easy. We should follow certain procedures, the standards we should follow, and because that is a very unsafe place to be in the case of the industrial robots. So robotic accidents can occur during programming. That's what I told you. Robotic accidents will not only it occurs during the operation, it can also occur during the programming also. When you are developing a robot, and when a person is developing a robot, he wants to program the robot, and the robot sometimes will misbehave, because if you're writing the code in the wrong manner, there is some mistake in the code, so automatically the movement is replicated in the end effector. So that can actually cause some injury to the person who is working there, the programmer who is there, and also during maintenance, because during maintenance also the person may be cleaning the end effectors, or some repairs may be taking place. So that time also the robot accidents may happen. So it is not only during the operation, before the robot operation, post operation, like maintenance and repair activities also, the robot accidents can occur. So anytime the robot accidents can occur, and the area in which the robot accidents predominantly occur is the robot's working envelope. So you should always be aware of what type of robot you are working with and what is the working envelope of that robot. That is very important to ensure that your robot is always safe and you are so safe when you are working with the robots. some examples of robot accidents. I'll just quickly go through it. So in 1984, that was the first time a robot accident was occurred. So the die casting operator. So it is like it's a manufacturing industry. An operator was working in a die casting machine, and basically the robot is to remove the cast product. So I hope you understand about die casting machine. So the robot has to remove the cast product once the mold opens. So during that time, and after removing the cast product, it has to dip the casting into a quenching tank. Then it has to sit in the press, automatic trim press, whereas the excessive materials are removed. So that is the basic function of that robot. And when an employee, we noticed that the person who was working in that die-cast robot, he was trapped in between the right rear of the robot and the safety pole. So safety pole is something you are creating some barriers so that no one enters the area of robotic operation. So he was trapped between the robot and the safety pole. So that impact, he has suffered some injuries and he died after 5 days in an hospital. So this is the first instance where a robot accident was noticed. And some other notice, again, you can see the trapping incident. A worker is trapped between the robot, nothing but some support given. So basically the robot arm will push you or push the operator into that support, and the operator is getting trapped in between these two, between the robot arm and the support, and some bodily injuries will happen. Sometimes even crushing of body parts also occur. With that, he may have permanent disablement, or first two cases you can see both are fatal accidents. The third accident, the maintenance person climbed over a safety fence without turning off the robot. He wants to do some. The robot has stopped. That he noticed outside the fence, and he, without turning off the robot, he just climbed over the safety fence, and he wanted to work with the robot. And without his knowledge, when the robot started to work again, the robot pushed that person into a grinding machine. You imagine how that incident would have been. And the person died in the workplace itself. Similarly, so it is like the robot is pushing you. It will push you, and you will not have any control because it is pushing you with some high force. The head of a person was crushed between a conveyor and robot, and the robot was used to feed cows at the farm. So you should be very careful with the conveyor belts. You're working conveyor belts. The conveyor belt is a very dangerous point, and accompanied with a robot, person's head was crushed. Again, the person was crushed between a manipulator and a conveyor. Again, a robot and a conveyor, and the robot was moving the bricks from one conveyor to another at a brick factory. The person was again crushed between a conveyor and a robot. So if you see, mostly the type of hazard which is occurring is the trapping hazard. Means that a person is getting trapped between a robot arm and a support, or a person is getting crushed because of the force exerted by the robot. So you can always say that these are the predominant type of hazard that is existing in the industrial robot. So what I mean is, so these are the four major type of accidents which has been experienced by all this history, by all the previous experience. These are the four different types of robot accidents that have occurred. So one is the impact or collision accident. So that's what I told you, robot pushing you, or it is just forcing you it is colliding with you with some force, which can create some injury. And crushing and trapping accident, which is very severe, a robot's force can crush you. Imagine the force of the robot can crush a body part, or it can trap you between two machines, or between a robot's arm or some supports. And this will create a permanent disablement to the worker. He may lose a body part, or sometimes he may lose his life also. Mechanical part accidents, sometimes the robots, the grippers, the failure of the gripping mechanism or the end effector tool may create some mechanical accidents. The parts held by the robot, heavier parts held by the robots, will be thrown away from the grippers, and it can create some accidents. And other accidents, as I told you earlier, electrical hazards are present inside the robot. Electricity is a hazard. Then pressurized fluid. Again, in the case of pneumatic robot or hydraulic robot, there is a fluid present, and it is at high pressure. When you don't have proper, when the hoses of such pressurized fluids fail, or there is some damage, then the fluid will come out at a high pressure, also can lead to the accident. So these are the four major types of robotic accidents that have been occurring based on the history of the robot accident. So in that case, I will say that what are the different hazards. So before going to the hazard, again I will like to reaffirm the definition of hazard and risk. So a hazard is a potential of a substance to, or an activity or process to cause harm. Harm in the sense it is a damage to a life, it is damage to a property, or it can be a damage to the environment also. So any damage caused by a substance can be, then you can say that substance is a hazard. And hazards take many forms. As it is listed, it can be a mechanical hazard, it can be an electrical hazard, it is a fire hazard, material handling hazard is there, physical hazard, chemical hazard, biological hazard, psychological hazard. Mechanical hazard is very simple. You have the robot is a mechanical hazard. It is trapping you or crushing you. So it has the potential for trapping you or crushing you. So that is a mechanical hazard. Again, electrical hazard is present when there is a improper, when an electrical circuit is not protected properly, electrical device not protected properly, it can be an electrical hazard. It can create shock, or sometimes it can also create loss of life. Fire hazard is whenever there is a flammable substance and accompanied with a source of ignition, accompanied with a plenty abundant supply of oxygen, then the existence of fire hazard is always possible. The material handling hazard, as I told you earlier, in the case of conveyor belts, very riskier to work in conveyor belts. And physical hazards, noise pollution, light pollution, and vibration. So these are all termed as physical hazards. Chemical hazards are the hazardous chemicals which can create irritation, which can create explosion, which can cause damage to body, all categorized under chemical hazards. Biological hazards are mostly the bacteria and viruses. Psychological hazard is something related to behavior. So if you have some behavior, something you may be fear of something. So such hazards are categorized as psychological hazards. Some like sometimes there may be a worry about the job security. So these are all psychological. A person may have a worry about the job security. So that may be a psychological hazard. So these are all the broad categories of hazard. But whereas in robots, as we can see, we will be having the first four type of hazard predominantly, and in particular, mechanical hazard is very often existing in an industrial robot. And risk is nothing but, as I told you, risk is nothing but a probability. So probability of this hazard affecting the probability of this hazard creating the harm. So risk is the likelihood of the substance causing a harm, and risk is a product of severity of the likelihood. So how severe it is multiplied by likelihood. So if I say severity is high, likelihood also is high, then I can say that that is a high risk operation. And an example, so this is how the hazard and the risk is initiated. So that water is a hazard, it is present everywhere, it can drown you, but unless you jump into the water, it is not you are out of risk. So when you are jumping into water without knowing to swim, then it becomes a risk. So hazard is present everywhere. It is how you make it as a risk. That is how you have to deal in industrial safety. Again, gasoline or petrol is present. You are lighting a matchstick in the presence of gasoline or petrol environment. Obviously, there may be an explosion. The driving is a hazard. There are some inherent hazards. You are increasing the risk when you are using a cell phone while driving. So again, this is how the hazard and risk are differentiated. The hazards of industrial robots, as I told you earlier, most of the hazards by industrial robots are mechanical hazards. Robots are machines. Robots are nothing but they are machines. So whatever the hazards that are applicable to a machine, it can be applied as good as to the robots. So mechanical hazards are typically experienced in robots. Mechanical hazards caused by moving parts which can exert sufficient force. So robot, you have the robotic arm which can move and which can generate sufficient force to cause injury to the workers. Common mechanical hazards include cutting hazard, crushing hazard. So cutting hazard, you can see a rotation or a movement of some sharp object can cut the body. The crushing hazard is like a moving part exerting a force and crushing an operator into a wall or into a fixture. So that can be a crushing hazard. And shearing hazard where some high-speed rotation is of the machine and there is some shearing of body parts taking place. So these are some of the mechanical hazards. And again in belt conveyors, so the location where the rollers and the conveyor belts are meeting, you can see the points are highlighted. So these are all known as the nip points or the pinch points. So these points also can draw in, it can pull you inside. So this is the drawing hazards. The drawing hazards are few more in numbers, like chains and sprockets. When it is rotating, it can pull your hand, it can draw in your hand or fingers into it. Rack and pinion gears, machine gears, pulley belts, counter rolling rolls. So these are some of the mechanical hazards. An entanglement hazard is nothing but, say for example, your cloths are there, your cloths are getting entangled with the rotating shaft and you are pulled into the machine. So that's why generally when you are using the operators are operating a machine, they are supposed to have the proper safety wear so that there is no loose parts or loose cloths are coming out of their body. So the typical hazards experienced in industrial robots are the mechanical hazards. Mechanical hazards are nothing but are caused by moving parts which exerts sufficient force to cause injury to the workers. The sources of hazards in robots, you can see the sources of hazards are listed. human errors. So any malfunctioning in programming, any mistake in programming, or activating the peripheral equipment like your support equipments in robots without the knowledge or without connecting the proper sensors, or sometimes over familiarity also is a human error. Some persons may be very familiar with the robotic operation, so but sometimes he may not follow the standard operating procedure which are supposed to be followed. That will account to the human error. And control errors, your faults with the control system, again some failure in the sensors, some failure in the end effectors, some errors in the software, electromagnetic interference. The electromagnetic interference in the sense when you are using some mechanical limit switches, like using some mechanical limit switches. So there should be some electrical current passing into it. Only then the limit switch will be functioning properly. So when there is some malfunctioning of the equipment or electromagnetic interference from a nearby equipment may also affect your robot. So that comes under control errors. Then unauthorized access. So unauthorized entry into robot's safeguarded area. So your robot will have a working envelope, and beyond the working envelope there will be a safeguarded area. And that safeguarded area is very, very critical. No unauthorized person should be allowed to enter into that safeguarded area. Mechanical failures. Obviously, excessive payload. When you give more payload to the robot, it may fail. Robot may fail. That is one point. Sometimes the payload may be thrown away. It may cause some serious accident, and that is a cause of mechanical failure. Joint failure. The joints of the robots may fail because of the wear and tear, and end effector failure, the failure of the end grippers, also because of the non-maintenance, no proper maintenance. When you don't maintain them properly, such mechanical failures occur. In environmental sources, as I told you, the electromagnetic or radio frequency interference. So when you're having another electromagnetic or radio frequency interference from a nearby machine, so there may be some interference, and there may we are using a radio frequency interference for just say, for example, you have a radio frequency receiver, and when you go near to the robot, by sensing the radio frequency or by sensing your device, the robot should reduce its speed. But when there is some interference with some nearby object, and when you enter the robot's working envelope, and the machine does not slow down, the robot does not slow down. So such environmental failures also occurred in robots. Then power systems, as I told you, we are using 3 different powers. One is pneumatic, hydraulic, and electrical power sources. And any malfunctioning in these power sources can create an accident in the robot. Electrical overload can fail the robot. And in the hydraulic power source, there is a hydraulic oil which can be flammable, which is flammable in nature. And this hydraulic oil is present, and there is also electricity present, and there is an oil. You can see that fire triangle is shown here. There is a flammable oil or flammable liquid is present, and there is some hard surface or some electric equipment or the static electricity. A very common source of electric spark is the static electricity. So static electricity is nothing but whenever there is in an electrical circuit, there is a insulator at some particular location, and the electrons from conductors will try to the insulator will not allow the electrons to pass through it, but because of the high voltage or because of the voltage of the system, the electrons will be accumulated at that particular junction where the conductor and the insulators are meeting together. And when the voltage is still getting increased, there will be a small jump of the electrons. So that is known as the static electricity. Very common example is your welding, arc welding. So arc welding, you just touch the electrode with the base material, you just remove the electrode or just lift the electrode, and there will be jumping of electrons from the electrode to the base material. It is similar to that. So the power system, the stored electricity or the static electricity is there as a source of ignition, and you have flammable oil. When there is some leakages, there is the flammable oil is present, and oxygen is present abundantly in the atmosphere. When these three combine, then the fire will be generated, or there may be a fire may occur. So again, fire hazard is also present in the robot, and improper installation. Improper installation is inadequate planning of the layout. So a robot has to be planned so that there is a proper working envelope given, and apart from the working envelope, there is some space given for safeguarding the robotic environment. Only then you can have a proper installation of the robot. When you inadequately design the layout, when the space given for your robotic assembly or the workstation is less, that also can act as a source of hazard. Moving on to the next one, safety with industrial robotics. So I'll just give a brief idea about what are the other important safety issues with the industrial robots. So these are the major 7 practices you should follow to ensure your robot is safe and you are safe when operating the robot. So a robot has to be manufactured or remanufactured or rebuilt only based on the appropriate industrial standards. So I'll just discuss about the standards at the last part, so that I want to complete this presentation with the list of standards with which the robot industry is working. But first and foremost, any operation or any product without a proper industrial standard is always a threat to the life and the environment. So that you should understand. So the product should follow the safety standards, follow the industrial standard, and industrial standard in turn will take care of the safety of the product, because a product standard means the safety is also inbuilt into it. So when you want to manufacture a robot, you should follow the industrial standard that is applicable at that point of time, not a very old standard. You should always follow. You should always be in touch with the latest standard available in that particular for that particular product. The standard should be followed without any deviation. That is the first aspect of robotic safety. Second aspect is, to have a proper robotic safety, you should have proper risk assessment done at each stage of the product development or each stage of development of the robot. So the robot, you should do the risk assessment properly, and you can see the 5 major steps of the risk assessment is given on the right side. So identify the hazards, decide what might be the reason for the hazard or what might be the cause of the hazard, and evaluate the risk. So I told you, hazard is present everywhere, but how you convert it into a risk? By unsafe act and unsafe conditions. So you try to evaluate the risk and you try to reduce the risk in that particular hazard. Then you repeat this process again and again, so that your process is getting improved, your safety of the process is getting improved always. Safeguarding devices, which again in brief I will discuss in the upcoming slides. So steps of risk assessment. So these are the risk assessments. First you have to identify the hazards. Then you have to identify the persons at risk. Then you evaluate the risk level. So this is what I told you. There is risk assessment is always having 2 factors. One is the severity of the risk, severity of the hazard, with the probability of the start occurring. So when the probability is high and the severity is also very catastrophic, then you put at high priority, you work on this particular risk. You try to reduce the risk completely, or try to bring down the risk to a medium or low level. Then you start thinking about the other risk based on the severity and probability. Okay. Once you know the risk, then obviously there are hierarchy of controls for that particular operation. So you try to eliminate the hazard or substitute or employ engineering controls, administrative controls, or PPEs so that the safety can be ensured. Record. So one more important aspect of industrial safety is to document all. You should have a proper document for all the activities, for all the assessments, for all the investigations you are making. Only then it will act as a continuous medium, so that you need not start from the beginning. So when you have a proper documentation, you can build a very good safety system or structure in your organization. Then every time you have to monitor and review. Proper review meetings have to be held, and monitoring of this assessment procedures or hazard evaluation procedures have to be carried out. So the third point I'm going to discuss now, the safeguarding devices. What are the different safeguarding devices that are present? And before going to that, the safeguarding the teacher. So safeguarding the teacher is nothing but the teacher is the person who is programming the robot. So he is actually teaching the robot. So that is the actual meaning here. So the robot's teacher has to be safeguarded first, because he is the person who is going to be interacting with the robot before the normal operation. He is the one who is going to program it. So when a person is programming the robot, he may activate some improper functions, or there may be some improper sequences created, and this has to be identified. So for this purpose, whenever a programming is being done on a robot, the robot's maximum speed can be 250 millimeters per second of the robotic arm or the end effector. So this you have to keep in mind. So the speed of the robot has to be drastically reduced. The maximum speed itself can be 250 millimeters per second. It can be still further down, but it cannot be on the higher side. So at this speed, you can say that even though the robot hits the operator or hits the programmer, there may not be any serious issues. And then maintenance and safety training, again I will come back later. So now we will be discussing about the safeguarding devices. So ranges of safeguard for mechanical hazards. So as we have seen in the previous slides, we had some crushing hazards, tapping hazards, shearing hazards. But in general, the safeguards for these mechanical hazards are these sort of fixed guards. But these fixed guards are typical for a mechanical machinery, not for a robot. You can see this is not suitable for industrial robotics, because industrial robot is like it moves in that specific working envelope. It moves all over the working envelope, and here if I put a guard like this, then it will create a specific restriction of movement in in a particular joint. So I cannot have traditional safeguards which are used for mechanical hazards. So for that purpose, the safeguards are robot systems are very much simpler and straightforward. You have to go for perimeter control or protecting the perimeter. That's what they say. You protect the perimeter. And protecting the perimeter is like, even though you are protecting the entire robotic assembly or robotic workplace, you still have three elements or three zones into it. So it is more like an engineering control. You are trying to do an engineering control. So this, in the hierarchy of controls, it is an engineering control, because you cannot eliminate the robot. You cannot eliminate the robot. You cannot substitute the robot with some other equipment or some other machine. So these two things are ruled out. So obviously go for the engineering control. That is you put some guards. You control the perimeter. So perimeter control is like it is having 3 zones. So one is the perimeter of the work zone, and inside the work zone, this is the robotic envelope, or inside the work zone. And third one is the on the robot. So what are the safeguards that are generally followed in in this particular zones? So one zone, the first zone, you see adequate clearance should be given. So where you have robot and proper spacing should be given for the perimeter. So adequate clearance from the perimeter to the actual workplace should be provided. Then the fence, there should be this particular area has to be fenced. Then light curtain. So light curtain, you can see is marked in this red discontinuous lines. So light curtains, it is nothing but it is a laser light source. So it is running from one end to the other end. So there will be a laser light source, light generator, and also a receiver. And when the person is accidentally walking inside, so this light is getting disconnected. This rays of light is getting disturbed. So with that, there is a sensor, and the sensor gives the feedback to the robot, and the speed of the robot is automatically reduced, or the robot is completely stopped. So that is the one safeguard which you can use, the light curtain. And when you go inside the perimeter, inside the work zone, then you can use safety mat or presence sensor. So safety mat is nothing but it is similar to a mat where some piezoelectric sensors are there. So piezoelectric sensors, the principle is when you apply a force on the piezoelectric sensor, there is going to be electrical charges that is coming out of the piezoelectric material. So with this electrical charges, you can sense that there is some force is exerted on the piezoelectric material. So when you are walking on the piezoelectric mat, your walking itself will create some force, and this will give a electrical signal, and this will stop the robotic operation or slow down the robotic operation. Then the presence sensor, nothing but the cameras. You can have a camera inside the robotic workspace, so that a person who is entering the robotic work envelope, the camera will sense him, and it will give a command, or it will give some signal to the robot so that it can be slowed down. And zone 3 is particularly for collaborative robots. As I told you, as you would have come across in this entire workshop, the industrial robots are basically the conventional type of robots where the human interaction is very minimum, and collaborative robot where the collaboration between the humans and the robots are very high. So for this particular collaborative robot, there should be some limiting device. So the robot cannot move, or it cannot rotate beyond certain angle, or it cannot move beyond certain distance. So some limiting devices will be fixed. Also some collision sensor. So when I'm just working with a collaborative robot, it can sense my body, it can sense my body temperature, some sensor, and it slows down the speed of the robot. So these are some of this is a typical safeguard for industrial robotics, because I cannot have a individual fixed guard like this. I can protect only the overall envelope or overall working space of the robot. And you can see this typical example of the perimeter barrier, which is present in the industries. The perimeter is what the robot envelope is present inside, and the perimeter is far away from the robotic envelope, and the person who is entering into this perimeter should have authorization, and even some more controls, as we will discuss in the next few slides are present to control the entry of to ensure the safety of the robot. And again, fixed guards. So these are again a few examples of fixed guards of the robots. And interlocking guards. So fixed guard is one guard where the guard will be fixed. No matter the guard is removed or not, the robot will not have any feedback on that. Whereas interlocking guards are something, whenever you close the door, you can see some interlocking devices there. This door will be closed and this door closure will be sensed by this interlocking system. So there will be a small minimum electrical current will be flowing. So when in the circuit, when the door is closed, the circuit gets closed. So there will be a flow of the current. But this flow of current will be very, very minimum. It will be in a safe level. And because of this, the system will recognize that the doors have been closed. And once this signal goes to the electrical actuator, only then the electricity to the electrical actuator will be given, or the electrical power for any type of actuator. It can be pneumatic, hydraulic, or electrical, will be switched on only when this interlocking guards are closed. So an arrangement where the operation of one control or mechanism brings about or prevents the operation of the other. Only when the door is closed, the other operation is started. If you open the door, it means that the circuit is open, automatically the electrical power will be cut down. So the robot or the machine will automatically comes to a stop. And this you can see the presence sensing devices. I told you the light curtains. So it is a ray of light from a source to a receiver, and when you try to enter this particular envelope, this ray of light is getting disturbed, and this information is sensed by the robot, and the robot is completely stopped or it is slowed down. So this is the presence sensing devices, the safety light. The other presence sensing device is the laser safety scanner. So it is actually looking something similar to it. There is a laser scanner. So it actually emits laser light, and when a person is going near to this laser light, automatically some amount of laser is returned back to the sensor. So with that, it senses that there is some human or some object is approaching the robotic cell, and the entire operation will be stopped or slowed down based on the zone where you are entering. Say, for example, you are in the protection zone, completely the robot will be stopped, or the warning zone, the robot may be slowed down. So it depends on the definition of this particular zone. And this is the pressure sensing devices, as I told you. When you can see this yellow mat-like structure that is surrounding this robot, and this will have a piezoelectric sensor. The principle of piezoelectric sensor is to discharge electric charges when you apply a force. So as a human, with your body weight, you walk on this mat, you exert pressure, there is an electric charge discharge, which will give a feedback to the circuit and will stop or slow down the robotic movement. Awareness devices, as I told, this again it comes under the administrative control. What we have seen so far is the engineering control. Now you go to the next level also. You don't stop at the engineering control. You just give another set of control, administrative control, where in the top of the machine, in the robotic cell, you can have this type of beacon lights. So when the machine is running, there will be a red color signal given. I mean, the red color light will be glowing, which means that you should not enter, you should not come into close proximity to the machine. Or when there is some maintenance is going on, only the authorized person who is competent enough to carry out the maintenance can go inside it. Or when there is a green light is there, absolutely the environment is free, you can go inside and without any hazard. So such type of beacon lights are given, and obviously in any industry you will have this sort of signboards. So Signboards are an administrative control. It gives you information, but it's not still effective. You should follow that. It gives you a first-hand information about this danger that is persisting or that is existing with the robot. So these are some of the administrative control devices. And again, restricted space paints or labels. So you just paint your workspaces, paint your aisleways with some colors so that each and every color will mean a certain meaning. So if you have, say for example, an yellow colored paint, it means that it's aisleways or walking ways. In white, the equipment or fixtures are not otherwise color coded, so it is just for the equipment or fixture. When you have the red and white stripe, the area has to be kept clear for safety reasons. So there should not be any movement of persons in that particular zone. So such type in industries, the color coding is given for the restricted spaces, and this can also be adopted as an administrative control. So, and this information has to be given for the operators. The operator has to be trained on this. So administrative control should be followed by a proper training. As simple as that, you can say the hierarchy of controls are again applied to this robot operation, safe robot operation. As I told you, the elimination or substitution, eliminate human interaction with the robot. You cannot eliminate, you can minimize. That is what is possible. So after minimizing the human interaction, you go for this engineering controls, that is the barriers, interlocks, presence sensing devices. Then you come to the administrative control, which I have seen now, the beacon lights, signboards, restricted space paints, labels. You give proper training to the operators, safe work procedures, documents detailing the safe work procedures, and lockout tagout processes. All these things you can formulate the hierarchy of controls for a safe robotic operation. And personal protective equipment, obviously you can also wear that as to protect yourself, like safety goggles, face shields, earplugs, gloves, protective footwear, respirators. It depends on the environment where you are working. If you are working in a welding environment, obviously you need to have face shield, respirators, gloves. If you are working in a noisy environment where a material handling is taking place with some noise, then earplugs may need to be used. That footwear is generally used in industries. So these are the hierarchy of controls for the safe robot operation. The standards on safety requirements of robots. So these are the standards that are given by the International Standard Organization for Standardization, ISO, and a separate committee is there, the TC 299 division, which exclusively develops standards for the robotics. And you can see the standard for developing the robots, ISO 10218, Part 1 and Part 2. So Part 1 specifies the requirement for and guidelines for inherently safe design. So inherently safe design is very important. In operation, a product should be safer inherently. You need not give, so whatever the controls which you have seen, it is an external control. Inherently, if the process is safer, that is the best thing you can have, best thing we can have for a good, safe and healthier workplace. And you can have this standards for an inherent safe design. Similarly, Part 2 standards for robot system and system integration, which specifies the auxiliary components of the robots. And this ISO 218 standard is not applicable to non-industrial robots. Non-industrial robots are like the undersea robot, military robots, space robots, teleoperated manipulators, prosthetics, micro robots, which are used in surgery and healthcare. And these are all the non-industrial robotics. So whatever we have discussed today, or we had in our discussion, are all applicable to the industrial robots. Non-industrial robots are a separate class, which is not considered in the scope of this discussion. Again, ISO 15066 collaborative robot safety, ISO 20218 part 1 and part 2 safety design of end effectors, your grippers, your weld guns, so all the safe design, and safe design of manual load and unload stations where material handling robots, how to design the stations, that is also given in the standard. So this is the general standard given by international organization for standardization. And now in India also we have our own standards coming up. So Bureau of Indian Standards, BIS, and under BIS there is a separate division for production and general engineering, and section under the division we have a section specifically operating for industrial and production autonomous systems and robotics, PGD80. So this specific sectional committee is developing the robot standards for our country, and so far these robot standards are all adopted from the ISO standards which I have shown in the previous slide. You can see ISO 10218 is adopted here. It is again ISO 10218. All the earlier ISO standards are adopted, and all adopted in the recent years. You can see here is 2019, 2017, 2018. So we have only 5 standards in our country, and all being developed in the recent years with the help of the ISO standards. And broadly, these standards will be based on ISO standards, and some certain changes or modifications will be made for the Indian scenario. And the other countries' standards are also available. American National Standards Institute, ANSI, you can have the robot standards, industrial robots and safety, robot systems, safety of machinery, safety requirements for integrated manufacturing system. So each and every country, they have their own standards, but universally following ISO standard will be very much easy for interpretation, and also
Sir, are you there, sir? Sorry for the inconvenience from our speaker side. Due to some technical problem. He will join within a few moments. Till then, dear participants, patient.
Are you able to hear me now? Can you hear me?
Sir, we can hear you, sir.
Okay, just a minute. I'll share. I'm almost about to complete. Just,
Yeah, sir. Please,
connect.
sir.
So generally, we have some standards, and that ISO standard is the universal standard which is just being adopted, and the country-specific standards are also present, and the country-specific standards, like for India, we have our BIS standard, which is under development under the section Industrial and Production Autonomous System and Robotics PGD 18. So if you have any recommendations for developing our own standards, you can submit to this particular sectional committee because the sectional committee always receives information or recommendations from various experts. So any specific recommendations to the robotic system, robot standard development, you can submit to them. They will review it and they will take up into for further discussion in the BAS. So in that we have our BAS standards all recently being developed. So you can see the year in which it was first published, 2019, 17, 18. And the American National Institute, Standards Institute, also they have their own standards. And it is basically an adoption of again the ISO standard. So mostly the ISO standard will be universal to all the countries, and each and every country will have their own adoption, making some minor modifications suiting their own system and requirements. And also you have the Canadian System Standard, Industrial Robots and Robot Systems, specifications for robotic arc welding safety, is given specifically by American Welding Society for the welding robots. So what I mean to say here is, if you want to manufacture a robot, it has to follow any of these standards. Only then inherently you can ensure that your robot is safe enough. That is the priority, to have a safe robotic operation. The effective, so generally we can have an effective industrial robotic safety system of this sort of whatever the picture is showing you. This is an example for an effective industrial safety system. So you have the barriers where you are covering the perimeter, you are protecting the perimeter, and the barriers are also having some specification with respect to their height. And you can see the robot's envelope is well within the barriers or the perimeter. And you can see the awareness signal, you can see the safety mat, safety beam, the light which will protect you, will make the robot slow down or completely stop, then emergency stop button, then again enabling device, because when there is an emergency stop button, you stop the machine suddenly with an emergency stop, then you have to enable it with proper startup procedures. You cannot simply, again, you cannot start it like a normal operation, normal startup. Again, you have to have some maintenance issues and you have to start again in a different way. when you have an emergency stop. So emergency stop, you can see it is given at many places, which means that from any place you should be able to access the emergency stop. It is not that you have to go to only a particular location and you stop there. You operate the emergency button. So this gives you a typical idea about the effective robot safety system. But still, the robot envelope plays a major role. Any person, the robot teacher who is going to program, is going to work in that envelope, and that is the place where you have the most hazardous environment of the robot. And so whatever we have seen so far in this discussion, we have discussed only about the industrial robots, that too with respect to the convention, that is like the conventional and collaborative robots. The other robots which are not covered in this discussion, or whatever the standards which I shown you, which is not covering the other robots, are also existing, and so separate standards are available for the other robotic systems like service robots, AGVs, undersea and space robots, teleoperators, mobile robots, automatic storage and conveyor systems, mobile robot, prosthetic robots, and even a CNC machine is also a robot. So these machines and these robots, which are not covered in the category of industrial robots, they have separate class, they have a separate standards for them, and similarly they have a separate standard operating safety procedures for operating them. And so these are some of the references, the robotic standards which have been, which was useful, or which was referred while preparing this presentation. So many thanks for the opportunity given by Dr. Raju and the ATAL scheme, and also for many thanks for patient listening by the participants. So I have come to the end of my presentation. So any discussions, we'll have it now. So if there is any discussion.
Thank you, sir. Thank you for sharing your thoughts and elaborate knowledge about the industrial safety. We could grasp some safety terms. Thank you, sir. Now this session is open for queries. Participants are requested to ask your queries. You can unmute your mic and you can ask. And dear participants, could you all open your webcam, please?
So once again, I thank everyone for listening to me. If you are having any queries, please ask me.
Sir? Hello?
Yes. Yeah, please go ahead, please.
Sir, you are able to hear?
Yes, please.
Hello? Sir?
Yes, I am able
audible?
to hear you.
Sir, I am audible?
Yes.
Hello?
Yes, sir, you are audible.
Sir, you told so many safety aspects. How the robotic will have control for this hazardous and chemicals are all there, how it will identify that one and safeguard the human being?
So basically, it all depends on the sensors which you are using in the robot. So, say, for example, when there is a specific hazard, a mechanical engineering hazard, then the robot can sense with some, by giving some light beam, and the reflection from the light beam, it can sense some obstruction. Similarly, when there is a chemical you cannot directly sense, you cannot have an integrated system, but still you can operate the system, operate the robot where there is no chemical hazard is present. So that is why you need some maintenance procedures frequently to the operators or the maintenance people to go and check the environment regularly. If there are any chemical hazards present, they can remove or bring the notice to the safety officer or the authority concerned. But still, if you can still have the chemical sensors on the robot, but still the cost of the robot may be increased in that aspect.
And what kind of sensor they'll use for that one? For I may have acid or base or very dangerous substance will be there. How it will be? What kind of sensor they'll use?
I'm not exactly aware of the chemical part, but generally the gas analyzers will be used because the chemicals will be giving some fumes of gases. So some gas analyzer will be used for that particular sensor. So when there is a evolution of some nitrous oxide or sulfur dioxide, this will be sensed by the sensor. So it senses that there is a chemical present, and it will give the feedback to the robot or the computer.
Sir, in India, like any robot is being used in the any big chemical industries for safeguarding purpose? It is achieved? Any achievement is there? Huh?
For safeguarding purpose, we are not using the robots so far. We are the chemical substances or the robot should not come into contact with the chemical substance. That is the prime motive for the industrial robotics. So far, there is no known robot which is specifically used for protecting from the chemical hazards. Maybe welding robots are used where the fumes are generated. It is a chemical hazard. So it is used to replace the manual welding process by a robotic welding process.
Okay, sir. Thank you, sir.
Thank you.
Thank you for your lecture, sir. Thank you.
Thank you all, dear participants. Tomorrow it's our. Tomorrow it's.
Any other questions?
Participant, if you have any queries, you can ask.
Sir, so shall I ask one more question, sir, which I have doubt?
Yeah, please go ahead.
Not regarding the chemical, but if a fire accident happens on the top of the building, hello, in the 20th floor or 30th floor, hello, sir.
Yeah, please tell me.
In such a cases, there is a short circuit is happened. Whether a robot can help the people or rescue the people from that floor?
Actually, the problem we are discussing about the safety aspects of the industrial robots.
Safety only, sir. There is some short circuit is there in electrical short circuit.
Yeah.
Electrical short circuit is happened. Suddenly, there fire comes. We have to safeguard that the human being who is there.
No, for that purpose, we will be using a different class of robotics, the andro-humanoid robot, where it does the work similar to a human being, where it is not fixed in a particular robotic envelope. It is actually it can have its high degree of freedom. Whereas what the industrial robots we are discussing is confined to a particular environment, is confined to a specific work envelope. So it cannot move out of that work envelope. So that is the first point. Then the second point is even the electrical systems in that particular building will be having the appropriate electrical safety measures like the circuit breaker or your MCBs. So to identify any short circuit, and it will stop the flow of electricity to that particular wing or that particular floor. So that is taken care in the electrical safety aspect. Whereas the industrial robots which we are discussing is more like it is having a restricted envelope, working envelope, and it will never come out of that working envelope. Maybe this andro-humanoid robot, which is not coming under the industrial robotic category, can be employed if the organization is willing to invest and if the organization is ready to spend on such robots. then it can be definitely done. But that comes under the different class of robotics.
Okay. Thank you. Thank you, sir.
Thank you.